Okay, we are recording. What I would love as we go through this is if you can just interrupt and ask questions. So this is a topic that I just feel like is really important, and I feel like it doesn't get enough coverage in your undergrad. I think, although actually my feedback, I was going to say, so the University of Queensland is very strong on research methods of addressing issues with replicability in psychology. But my experience of when I've spoken to students that have come back from UQ is that this still maybe doesn't necessarily translate that much in terms of the teaching and the lectures that you get. So I think this is maybe just an opportunity for me to indoctrinate you with some important methodological stuff that applies to social cognition. So basically going to focus on transparency in science, and I'm going to make this argument that we as a field need much greater transparency. So there needs to be this kind of much greater openness in the way that science and the way that research is reported. So reported in the way that the articles are written up. It should be more transparent in the way that you run our experiments, and it should be more transparent in the way that we should share data much more frequently than what currently happens. So I guess one of the issues that I want to emphasize is that there is a lot of sort of mystery or hidden processes that go on within the research cycle. And this can sometimes lead to differences between the sort of reality of what happens in an experiment and the sort of face of what ends up getting reported in a publication. And we need to really open up this hidden research process, make it a little bit more open. And by doing that, we can have a slightly more trustworthy scientific process. So what are the problems? Well, I think in science, we have this big conflict for academics, for researchers, for someone like me, that you have this balance here that on one hand, you might think that all scientists have this overarching motivation and drive for discovering the scientific truth. What's important when I do research is to find out what is objectively true. So the goal of scientific research is to discover and present the objective truth. Yeah, that's a pretty straightforward, noble goal. And I think that's the reason why most researchers or scientists get into this field and what excites them. They want to find out effects. So we have this on one hand, motivates your work. But on the other hand, there's a slightly more practical or pragmatic motivation, which is that you need to publish academic papers. So in order to maintain a career in psychology, you've got to publish at a reasonable rate. So typically at least like 2, 3, maybe 4 papers per year would need to be accepted into a journal. And that's important for, both you keeping a job, it's important for you gaining grants. So for getting future funding, it's important if you care about these things at a reputational level, it's important for that. So we've got to balance these two things. And the problem with this is that if you look at what sort of papers get published, then the probability of getting a paper published is not necessarily purely a function of does it present the objective truth. What tends to determine whether a paper gets published or not is that it's currently a function of, firstly, significance. So is the effect that you're reporting, is it statistically significant? So if I test what's the difference between taking this drug and taking this drug, if there's a statistically significant effect, so P is below 0.05, that is much more likely to get published than if I find that there isn't a difference in the performance of my two groups. Probability of getting paper published also increases based on the novelty So if you study things that are a little bit surprising, that haven't been done before, they're more likely to be published than if you're replicating something that has been done in the past. We're also more likely to publish things that show counterintuitive effects. So if I study something and it's really obvious, it's much harder for me to get that published than if it's something a little bit quirky and goes against what you might naturally expect. And then research results that show really clean results. So in other words, there's no sort of messiness or ambiguity in the results that you're reporting. So traditionally, researchers end up being incentivized to produce papers that display all of these different qualities that mean it's going to be more likely to get published, even if this comes at the cost of the accuracy. So we might forego a little bit of this objective truth that, yeah, the objective truth is nice, but sometimes the data is just a bit messy. Often we don't get significant effects. And if it's hard to publish those, then we can be kind of convinced to produce papers that do fit into these different attributes or possess these different attributes. Now, if you want to end up producing papers that have all of these features, so they're novel, they're counterintuitive, they've got clean results, at one level, this might encourage you, or these incentives for getting publications in order to keep your job. They might encourage you to go down this really dark path of engaging in scientific fraud. And there has been numerous cases of this over the last decade that have come out. One of the most famous is the case of Diederik Stapel. There's also Dirk Smeesters, Larry Sanner, Jens Forster. If you go onto the website retractionwatch, I think .com, this covers all of the different retractions that go on in psychology and in other fields, which is just accelerating. In when this website first started, maybe 6-7 years ago, there were a handful of cases that they would come across where a scientist would have committed fraud. Now it's every week there are instances of scientists that are making up data, manipulating the images. So particularly within biomedicine, this is a real big issue. So yeah, this cases of academic fraud are accelerating, or at least our identification of academic fraud is accelerating. I think in general, it's really hard to know the current state of fraud in science. Not helped by the fact that there is nobody out there that necessarily polices or detects fraud in science. So a lot of the time it relies on individuals that are doing this kind of grunt work or working as like the fraud police. There isn't really any overarching scientific body that detects fraud. If you suspect an individual of conducting fraud, a lot of the time it involves a researcher reporting this to the university where the academic works. And then you kind of go into this black hole of whether the university care about chasing it up or not. But anyway, that's a talk for another day. So some examples of this, of Diederik Stapel, who has 58 retractions. So he said, I did not withstand the pressure to score, to publish, to pressure, to get better in time. I wanted too much too fast in a system where there are few checks and balances, where people work alone. I took the wrong turn. And yeah, this is a big issue when a lot of people, you're working on your own. It is incredibly easy to fraudulently manipulate your data. So he was a very famous social psychologist. But if you read his book called Ontsporing, there's a translation of it in English that's out there that I think is a fascinating read. It talks a lot about his personal motivations of why he started doing this. And generally it was through a sort of initial accident that he realized, yeah, you know what, this is super easy. I can just come up with a fake Excel data set. Nobody is going to question whether I actually collected that data or not. And then I can just publish these things. And he was also combined this with actually quite a lot of insight that maybe a lot of the theories he was testing were genuinely effects that existed. But it was just a lot easier for him to make up that data and create it rather than go and collect it in the real world. Another famous case more recently of Michael Lecoeur. So he was a kind of up-and-coming social psychologist who did a groundbreaking study that was published in Science that looked at what would happen if you gave people a really brief interaction. So in our lectures on attitudes, we came across this idea that if you had sort of intergroup contact, sometimes it's still very difficult to shift people's attitudes and perceptions towards other groups. And he published this very kind of groundbreaking study that said if you had a very brief interaction on the doorstep with a homosexual person, that this would increase the positivity of people's attitudes towards homosexuals at a later time point. And this fraud was only discovered when another PhD student wanted to replicate his study and basically realized that if we replicate the same methodology, this is going to cost us $1 million to do it. And it led down this big wormhole of he was then, so this guy, I think John Brookman, was asking Michael Lecoeur, how did you run the study? How did you do this? And he started explaining his methodology. And it turned out that there wasn't actually any survey. He gave a list of like fake employees to try and cover his tracks. And this sort of all unraveled to realize that, yeah, he must have made up this data. So there's this whole field that looks at fraud. And I think it's a really fascinating issue of what motivates people to do it. And it's definitely a problem in science. But I think it's important to realize also that it's not the big issue. It's not the issue that is explaining why there might be a replication crisis or why researchers might be doubting the credibility of research that's published sort of a decade or so ago. So it turns out that there are many other factors that don't necessarily fit into this clear definition of being fraud, typically because they've become part of our normal research culture. But these practices do really harm the accuracy of science. These have become known as this kind of very sort of devious, or it almost sounds like a cheeky thing to do. They've become known as questionable research practices. So these are where we can take decisions in the design, analysis, and reporting that all increase the likelihood of achieving a statistically significant result and therefore a positive response from journal editors and reviewers. So in other words, we can analyze, design, and report our studies that make it more likely to get published, but move us maybe a little bit away from the objective truth. So if we look at this combination of factors that all get lumped under this term of QRPs. So QRPs means questionable research practices. So one of these is p-hacking. So we can analyze the data in multiple ways until we find a desired result. We'll see an example of this in a minute. We can also engage in hacking, so hypothesizing after the results are known. So this is where you might run a study and we have one hypothesis or one expectation, and then something really weird comes out in those results. And we decide that, you know what, I'm going to rewrite that introduction to the paper. I'm going to rewrite my hypothesis to say that I expected that these effects might come out. There's also issues with publication bias. So this is where we have selective reporting of results and or studies. So this can occur at the journal level, where journals are less likely to accept papers that don't have significant results. But it can also be the case that if I run a study, so say I'm a scientist that has lots of money, and I run 10 studies to try and see if computer games make people more aggressive. Now, I've got lots of money. There's a funding agency that kind of dislikes video games, and they want me to find not, maybe that's a little bit too harsh, but maybe there's a kind of some expectation that you have where you expect computer games to encourage aggression. So I could run 10 studies, and maybe in 8 of these, I don't find any effect of computer games on aggression. But in 2 studies, I do find an effect. So what I could do is just ignore and basically put in my file drawer the 8 studies that didn't work and just report the 2 studies that did show an effect. And you can see how that might be problematic. So if then when you search through the literature, all you're seeing is papers that do show that video games lead to aggression, and what you're not seeing is all of these papers that are hidden in a file drawer somewhere. Massive issue. We then have issues with underpowered studies. So we might not run enough participants. So we might not have enough money or resources to get a big sample. And then if we're doing this, we end up with just noisy data. Another issue is optional stopping. So this refers to, and again, this used to be a common way that researchers would approach the studies, is say, again, we've got our researcher that wants to show that video games lead to aggression. What I might do is I run 40 participants in my lab study. So they're playing a computer game. Then I see how aggressive they respond to something, or could measure on a scale their aggression tendencies. Maybe I run 40 participants and I put my data into my Excel sheet, into my software, and I run the analysis of, do I have an effect? And maybe at 40 participants, there isn't anything. So then I do it again and I collect a few more and I test it when there's 60 participants. And there is an effect this time. Now, what you could do is you just stop at that point. And I think, yeah, okay, that's the end. I'm going to write up that experiment. And we know that doing this can make you more likely to find an effect when one doesn't necessarily exist. So if you're constantly testing at every different time point, so after, say in an extreme example, after every participant you run in a study, you could test, does the effect exist? If you do that every single participant and then stop as soon as we get a significant effect, it's a bit of a dodgy or dubious way to do this. So there's a nice demonstration of how we're capable of hacking our way to scientific glory. So what you can do at some point, and the link is obviously in the slides for this, but you can have a look in this 538 article, which I think gives a really nice introduction to the potential for p-hacking. And again, I'm saying that a lot of the time, this was a default way over a decade ago to go about analysis. So if you've run a study, if you invested lots of money and you need to get a publication out of it, there is a strong tendency to analyze that data in multiple ways. And often you can convince yourself that what you're doing is appropriate. So in this scenario, we're being told you're a social scientist with a hunch. The US economy is affected by whether Republicans or Democrats are in office. Your goal here is to try to show that a connection exists using real data going back to 1948. For your results to be publishable in any academic journal, you'll need to prove that they are statistically significant by achieving a low enough p-value. So let's start off with, we can choose a party, but we're going to choose the Democrats here. Now what we're plotting is the economy on the y-axis and democratic power on the x-axis. So we want to end up finding a significant correlation that kind of moves up in this direction. And at the moment, when we put in, so we've got different indicators that can contribute towards our measure of democratic power. Now, at the moment, we're just starting with the amount of Democratic senators. We've also got indicators of the economy. So at the moment, we've got employment and GDP. We can also factor in other options here. So we can weight certain more powerful positions more heavily. So there might be specific positions in the Senate. So the Senate leader, maybe we could value that more strongly. And if a Democrat is the Senate leader, that gets a little bit more weight in our model. Now, at the moment, when we run this, we get a p-value of 0.06. And that's like, when you run that, you're thinking, man, it was so close to academic glory. So what you might do as a researcher is think to yourself, well, okay, senators are important, but you know what really matters is the president. So without the president being a Democrat, so we put this in, you know, well, that's kind of messed up, our p-value here. So maybe we think, what might be a good option now? Maybe we could take out our senators. Okay, then. The senators, yeah, actually, you know what, we should leave those in. Maybe it's the representatives as well that are important. And you know what? We put the representatives in. If we're going to do that, what we probably should do is also put the governors in. So we'll put all of these four in. And that makes the most sense, right? And now if we do that, we get a p-value of 0.01. So we show that the Democrats have a positive effect on the economy. And what you might do as a researcher then is sit back and go, yes, okay, I found a significant effect here. It seems plausible when I explain what factors go into this. I am going to send this for publication, and most likely, as long as everything else is written up well, that'll get accepted for publication. Does that make sense? I would be super happy if you can ask questions as we go through about anything. So we've got this issue, clearly, with a lot of these questionable research practices or p-hacking. And if we look at the timeline of how do we know that this became an issue? So how do researchers pick out that, you know what, our field is not as good as we think it is? And I'm going to skip ahead. There is actually a lot that goes on from the 1960s where researchers such as Paul Mill, Jacob Cohen, multiple researchers that have basically popped their head like a meerkat above the parapet and have gone, you know what, guys, we have real issues with what we're doing here. We have issues with the way that we analyze data. We've got massive issues with the power analysis. And everyone else in psychology kind of like, yeah, you got a good point. But you know what? I'm just going to carry on doing this research the way that I do it because it's working all right for me. Okay, great point. And this kind of went on for, yeah, 50 years almost. And one of the real spurs in the recent decade is in 2011, Darrell Bem published a 9-study paper demonstrating evidence for basically precognition or psi. So this is the idea that people are able to predict the future. So they're able at an above chance level to predict what is likely to happen next. And he did this in a series of 9 experimental, so using the typical sorts of methodology that we might use in the very best social psychology experiments. So it would be, one example is a computerized task where you've got 3 boxes that might appear on a screen, and you need to predict what is likely to appear in one of the boxes. And he showed that people were above chance level at predicting certain stimuli. So I'm not going to go into the details here, but there were different stimuli. One of these was like pornographic stimuli, and people were more likely to predict if a pornographic stimuli was going to appear hidden in the box. And he basically used this as a kind of convincing evidence that people must be able to predict the future if they're getting above chance responses on this. And as everyone looked through the methodology of these designs, it was hard to really find any fault. So it was hard to criticize the approach that was described in the method sections. And around about the same time, or in response to this article, so you kind of have an option here of deciding when somebody publishes a paper showing that people can predict into the future, what is it that you trust more? Do you think that people can genuinely predict into the future so that this paper is showing a genuine effect? Or the alternative is that there is something going wrong in the way that scientists are able to conduct their studies and report their research that means that this paper is able to actually show an effect. And I think for most people, they realize that maybe our system of publishing is the thing that is broken, rather than people actually genuinely having some sort of precognition. So to explore this, there was Joseph Simmons, Leif Nelson, and Yuri Simonson, which are, I think they're all behavioral economicists. What's the word that I'm looking for? Anyway, we'll skip over that. They do behavioral economics. And they published a paper basically showing the corrupting influence of what they called researcher degrees of freedom. And that is exactly, or one component of this is exactly what we did when we just hacked our way to glory, using the example of the Democrats in power. And they used a range of simulations to show what happens to the chance of actually finding a statistically significant effect, given that there is no true effect out there. So say if we're studying something that there's no difference between these two groups, what is the chance of us actually finding a difference between two groups if we've got the flexibility to analyze that data in multiple ways? And they picked out just 4 different properties here. So one is, say for example, you've got 2 different dependent variables. So in the example that we had earlier of the measure of power, maybe we've got 2 different indicators of power, and we can flexibly decide which of these 2 dependent variables do we want to include in our analysis. We can also do this optional stopping. So if we're able to run our experiment, we can run our analysis, and then if we don't see a significant effect, we can add some more observations. So we can add some more participants. Situation C is, say if I can analyze that data and I can decide whether I control for some potential covariate. So say if I've measured, we'll go back to our example of the video game and aggression, maybe I've also looked at the sex of each of the participants. So some are male, some are female, and I could decide that maybe it's only males that get aggressive after video games. If I have the option to either include or not include sex in that analysis, that's another factor. Situation D is whether you've got the flexibility to drop or not drop one of these 3 conditions. So again, say you run an experiment, and maybe in the case of the video game one, we run it using a violent video shooting game, we run it using a game that has sports, or we run it using a neutral or like a strategy-based game. There we've got 3 conditions, and we might look at how do each of those affect aggression afterwards. If I run those 3, and I've then got the flexibility to decide, you know what, that neutral condition, that didn't matter. We shouldn't have included that. I'm just going to exclude that one. And what I'm going to do in my final analysis is just include the sports and the violent shooting game and see how they differentially affect aggression. And what they show, and this might be a little bit hard to interpret on there, but we are looking at what is the probability in percentages of you finding a significant effect if you use one of these degrees of freedom. So let's just look at this middle column here. So this is, what is the chance of us finding a significant effect? So this is something below 0.05 if I have this opportunity. So if I have 2 dependent variables up my sleeve, and it gives us a little bit more of a chance. We've got a 9.5% chance here. And again, for each of these, you can look at them individually. Situation, yeah. So each of these gives us a small extra bit of chance of actually finding an effect. The interesting bit here is right at the bottom, is what happens if I've got all of these different like bits of flexibility in the way that I can run this analysis. So if I've got different dependent variables I can pick from, if I can add more participants if I don't find an effect, if I can control for different covariates, and if I can exclude a condition that I don't like, if we combine all of those, then what they end up showing is that if your data is just pure random noise, through these combinations, you have a 60% chance of finding a statistically significant effect. And basically that was a sort of light bulb moment for scientists, that they know that researchers are often doing these, and they're often not caring about doing any these too much. And they didn't quite realize how easy it is when you combine these to find an effect when definitely nothing exists. Does that make sense? Any questions? So we then have the issue of, I'm kind of making this claim that researchers are actually using these questionable research practices. If you don't believe me that it was prevalent, so this is Oliver John, Loewenstein, and I can't remember his name, Prelek, asked 2,000 psychologists about their involvement in questionable research practices. So these are a list of different ones that are plotted down here. So for example, failing to report all of the dependent measures. So whether you run a study, you measure multiple outcomes, and then in my published paper, all I report is the ones that showed me a significant effect. Collecting more data after seeing whether the results were significant, failing to report all conditions, etc. And the one I want you to really just focus on here is the one in the dark bar. So this is indicating what is the self-admission rate. And you can see that, what have we got here in the numbers? Ignore the numbers. They are a little bit different, are estimated from a slightly more complex measure. But we can look at, for the self-admission rate here, so over 65% of researchers report only reporting dependent measures that showed a significant effect. Selectively reporting studies that worked, over 50% of researchers admitted to doing that. So we've got this publication bias that is kind of rampant and common here. So these are a pretty big indicator that, yeah, not every scientist or researcher is doing this, but it is something that is relatively consistent and frequent across the field here. It's not only an issue in psychology. So this is some data that comes from ecology and evolution, where again, if we look at similar sort of questionable research practices, so these are ecology in dark blue, evolution, science, and you can pick almost any field. So whether it's the journals of marketing, business, what else are good examples? Medicine, cancer research, etc. Similar sort of pattern of high levels of questionable research practice engagement. So we've got this understanding that people are doing something a little bit naughty in the way that they analyze the data and the way that they report it. And they're not necessarily reporting the objective truth. But it took until 2015 until we started to really see what is the actual impact of this systematic use of questionable research practices, and people only publishing the significant effects and basically hiding the things that aren't statistically significant. So it's only in 2015 where we had a real good insight into how does that influence the reproducibility, so in other words, the credibility and the trustworthiness of psychological research. And to demonstrate this, there was a massive collaboration by, I mean, over I think 100 researchers are on this paper, where everyone decided to team together and replicate 100 experimental and correlational studies that have been published in leading psychological journals. So again, they picked these studies that they were going to replicate effectively at random. So they said, we're going to pick these good journals and we're going to pick a random selection of studies, and we're going to see how easy is it to replicate these. Now, the reason that random selection is important is it's not the case that they're picking research findings that they think are a little bit dubious. They're giving the kind of best benefit of the doubt here that it's a random sample. So what would you expect in terms of why they would be able to publish it? Yeah, so those of you that have to leave right now, It's recorded, so you can jump in and watch this later. So what would you expect in terms of 100 studies? What would you think would be reasonable for a field as a number of those 100 to replicate? And when they run these replication studies, they're running them typically with a bigger sample size than the original one, but also using the original materials. So they go to a lot of effort to replicate as closely as possible that original design. And I think what most people would expect is that maybe 80, maybe 70% of the studies find the same effect as the original one. And yeah, maybe just down to chance, there are a few studies that don't replicate, that we just got unlucky with, and were what is known as false positives. So false positive refers to where you basically incorrectly find a positive result. So what we've got plotted here is the outcomes. On the left-hand side are the p-values. On the right-hand side is the effect sizes. So this dashed line here is 0.05. So indicating that in these original studies, almost all of the p-values were below 0.05. So almost all of them were showing conventionally a statistically significant effect. Whereas if you look at the distribution of the p-values for the replication studies, these are sort of all over the place, that you have a slight bunching down towards the bottom, that some studies are below 0.05 and are replicating. But for a lot of them, the p-values fall in this kind of relatively even distribution across the field of not being statistically significant. And similarly with the effect sizes. So this is indicating the magnitude of the effect, or the magnitude of the difference between two groups. And again, in the original studies, majority of these show pretty strong effects, where we get this distribution that varies across, many showing no effect, and some even showing the reverse effect. And if we quantify it, we end up seeing, I think, 36 or 37 of these original studies ended up effectively replicating. So 36 of the studies had a p-value in the replication below 0.05. It's not necessarily the best indicator of a successful replication, but anyway, that's technical. I think the key point here is that this replication was like, holy crap. Our science is nowhere near as robust and as replicable as we thought it would be. And there's been notable failures that come out of this. They also give me a great opportunity to put some GIFs in. So ones that we talked about already was the social priming research, which is again a very controversial area. If you've ever come across the topic of ego depletion, so if you go to Queensland, there's currently Roy Baumeister, is a lecturer at University of Queensland, and he's a very famous proponent of this idea of self-control as being this limited resource, especially something that had a kind of biological mechanism, that self-control was underpinned by the glucose level in the brain. And when that level of glucose depletes, we lose our self-control. And that's been pretty convincingly shown, but there's no plausible relationship there. And again, like the work from Amy Cuddy on power posing, that a short posture manipulation can increase these hormonal markers of testosterone and lower cortisol. Generally, the evidence points towards the fact that that's not the case. And these are important because they're things that are so popular in TED Talks and everyday science communication, that it's turning out a lot of the stuff that we're constantly telling the world that, hey, psychology has got this cool finding that you can learn from. It turns out, yeah, not really. Maybe we need to backtrack on this a little bit. So I think one thing that is also worth realizing is that we've got this model of how science is meant to work. So if you focus on just these blue arrows and the black text that is in between them, this is something known as the hypothetico-deductive model. It sounds really fancy. It is kind of fancy, but it is the idea that you start off at this step here. So we start off with specifying our hypothesis. Pretty simple. I think that violent video games are going to make people more aggressive. That would be a hypothesis. You then go and design your study. After you design your study, you collect that data. You collect that data, you analyze that data. You've analyzed that data, you then make a subjective interpretation of that data. And then after we've done that, we publish our experiment in a journal. And one of the things you can see in here is how each of these different sort of questionable research practices or influences have an effect at different levels of this hypothetico-deductive model. So one of the things we can see in terms of what hypotheses do we end up specifying, typically we tend to pick novel hypotheses. So if I'm coming up with a hypothesis, I want to test something new. I want to test something cool, counterintuitive, flashy, exciting. I don't often want to test stuff that has already been examined. So that leads to one issue that generally in psychology, we tend to have a lack of replication studies. Well, we certainly used to. So 1 in 1,000 papers is replicating previous research. And that's kind of staggering that 999 out of 1,000 want to go and do something new. So how do you get any understanding of what the state of the field is if we're not replicating stuff? When we design and collect that data, one big issue is that we often don't collect data from enough participants. So we have what is known as low statistical power. And again, this is too technical to do justice and get into now, but we know that when you run a study with not enough participants, you end up being more likely to find false positives. So if we're collecting a bunch of noise and an effect doesn't exist, if you test lots of participants and analyze that data, it'll tell you that there is no effect. Whereas if we only test a few, that effect size might kind of jump around and be a little bit noisy. And then just by chance, with only a few participants, we might accidentally find a significant effect where one didn't really exist. This process of analyzing our data is where we can engage in p-hacking. And then when we decide to publish or not publish an experiment, we can engage in this kind of publication bias and a lack of data sharing as well. We can also do this hacking. But anyway, I think it gives you an insight that each of those corrupt the process at different stages. So I think we're at a realization that the current state of affairs is that the current practices are not working. They are a bit of a mess. So it becomes easy to publish false positive results. Maybe before we jump onto this, Kamori asked a question 13 minutes ago. Why do some researchers want to publish in prestigious journals like Nature or Science? What do you think are good reasons for publishing in a prestigious journal? So I think the most important of those reasons is for your academic future, your academic success. So a publication in Science or Nature is going to lead to both interest from your own current department where you work, is going to want to keep you, might make them more likely to give you a tenured long-term position. It might make you very attractive to other departments that offer you jobs. There's also a significant reputation. So given that it's a prestigious journal, other researchers are going to read that paper and they'll see, okay, you're published in Nature. Journals also have something known as an impact factor, which this impact factor relates to the number of times that papers are published in there that get cited by other journals. So Nature and Science have impact factors of something around about 30, which is huge. whereas most social psychology journals have an impact factor of maybe like 2 or 3, 4 or 5 maybe. Anything above like 3 or 4 is generally considered good or respectable. And then others might be much lower. So at one level, scientists might use this sort of heuristic that stuff that is published in high impact or prestigious journals is of a better quality. And there's very little evidence a lot of the time to suggest that that is actually the case. So if you look at the replicability rates of stuff that is published in a high versus low impact factor, there's not much of a relationship. So the stuff in high impact factors is often less replicable than stuff in low impact factor. There's also in some societies you get financial incentives. So rather than just the opportunity for career success, you can actually get direct financial benefits for publishing in a high impact factor journal. So China had a model until very recently where they would pay their researchers a bonus of $1,000 per impact factor of the journal that they published in. So if you published in Science, let me just have a look. What is the current impact factor of Science? So the impact factor of Science is 41.845. So if you get a publication in Science, you would be paid $41,000 US. And for a researcher, that is a substantial bonus that you could get. China and their academic model has kind of realized that, yeah, what this leads to is pretty bad corruption, that there are a few bad cases of individuals that will, especially if your data is maybe looking okay, it's suitable for publication in a journal, but maybe not perfectly clear enough to get published in Science, that would encourage you to manipulate your data, maybe a little bit to make it look cleaner. If it's going to give me that prestige, it's going to give me $41,000 US. Yeah, it's worth the risk. And there's not necessarily many punishments. Although saying that, I think there was the death penalty has been proposed, or maybe it was even, I think it was proposed or discussed for some researchers that were caught out engaging in this. So yeah, there is a substantial punishment or cost, for, at least within China. But anyway, I think we get to the state where the current practices are not working. And if you survey researchers and ask them, is there an issue within psychology? The majority of say that yes, we've got this significant crisis. Some researchers say yes, there's a slight crisis. I do not know what a slight crisis is. That sounds like having a small case of a pregnancy, or slightly pregnant. It feels like there either is or there isn't a crisis. But in general, I think most researchers agree that there is a crisis. So it's hard to know what effects exist, what we should be trusting. And the general consensus here is that we need to change the way that we do science. So given that we've got that bit of a mess there, you can leave this in the chat. That what solutions, actually in Pear Deck, what solutions can you think of? I've not shared the Pear Deck with you, have I? Sorry. I'm only going to chat about this for 10 more minutes, but let's just do this. Or you can comment in the chat whilst I'm loading this up. I'll share it for now. So what solutions can you think of that might help to improve the robustness of research? So redesigning research institutions and funding. Yeah, in what ways might you redesign them? Is it possible that journals that may not be as prestigious may contain more significant studies that are replicable, but may contain less novel findings but are important? Yeah, absolutely. So I think in some of the low impact factor journals, you definitely get a lower degree of novelty per se. And I think it's just a real mixture in the robustness and replicability of those results. So I'll share with you in the chat. If you want to join in on there, if it's easier than the chat group, you are welcome to. Stop assigning so much weight and importance to prestige. Yeah, absolutely. So I think there are certainly shifts at the moment to try and encourage the publication of reproducible and open research, as opposed to just stuff that is in high impact factor journals. Fund researchers regardless of research success. Yeah, so on the surface of that, that sounds good, but then you need to make a judgment somewhere of who do you end up funding. So there's a limited pool of funds that you can use for researchers. So the challenge with there is what metric do you end up choosing to decide who should and shouldn't get these research funds? Oh, retracted response. Yeah, that's a good point. A journal is a journal. Maybe having one common journal for each field instead of molding research to fit a prestigious journal. Yeah, certainly the publishing model, it seems a little bit ridiculous that you do have these journals that develop prestige. So I think when they started off for most of these, they almost started off as a kind of club or a community where you would have a certain level of kind of intellectual academics would group together to form that society. And then these journals would originally start off as kind of being part of that society. So there would be the publications and there would be peer reviewed by other members of the society. And the prestige would work that to get it published in the higher level ones, you would need to have it approved by more prestigious, more rigorous peer reviewers. But yeah, that's a good point. Encouraging researchers to try and replicate more past studies whilst finding ways to improve those past studies. Yes, absolutely. So this is one shift that we're going to talk about very briefly, is that replication studies are definitely encouraged much more and becoming much easier to publish. Something I've done this semester is asking the students that I supervise for their senior project is to, rather than come up with a novel research hypothesis, is to replicate existing findings that are out there. And it's been really interesting. Yeah, it turns out that we had some successes and some failures in the replication. Anything else before we move on? It's a good point. Platform to propose research questions freely so that those with less connections and opportunities have more chances to get funded. Definitely the diversity of where funds get distributed is an issue. Yeah, I mean, again, you then have an issue of still, how do you decide with that limited pool who gets it? So there are discussions at the moment of whether it would make sense, rather than getting researchers. So at the moment, the typical method is you submit a grant to a funding body, and then based on the quality of that grant submission, they decide whether you get funding for your research. And this takes up a huge amount of time. And it also, yeah, it does at some level. So these grants are often submitted anonymously. So they're submitted blind, that you don't know who is submitting this grant. So in some ways, those people with connections don't necessarily have a privilege or a bias towards being accepted. But there is discussion over whether these funding should be distributed as more of a lottery. So funding bodies that have done this have actually shown that, yeah, if we just choose at random who gets this money, that it tends to lead to just as good outcomes as if people are competitively applying for the funding here. Okay, Thanita, does pre-registering your findings and hypothesis have any impact on the credibility and reliability of the study? Yeah, maybe it does. Absolutely does. So some of the solutions that are required is fundamentally to try and increase transparency in this entire research process. So there's an encouragement at the moment to try and fully disclose these methods and the planned analysis, fully disclose your results and your data, and distinguish between, if we're running an analysis and I'm reporting it in a paper, the person that is reading that analysis should be able to distinguish between what is analysis that I've just run in an exploratory way because something unexpected came up and I thought it would be cool to test this, versus analysis that I thought about in advance and I said I would run. And if we're running frequentist tests where you analyze stuff, and basically you can think about it, if you run a test that has a p-value in it, this has to only be confirmatory analysis. You shouldn't really be running anything that gives you a p-value on an exploratory. And that's not to say it's not the case. Everybody often runs exploratory analysis using frequentist tests that give you p-values. So distinguish between those and then improve research design by conducting more highly powered studies. So some of the specific solutions to actually do that is firstly engaging in pre-registration. So reduce, and this targets p-hacking and hypothesizing after the results are known, by asking researchers to explicitly, in advance of collecting their data, so before you go and run this study, you would write down what are each of the steps that I plan to do for this study. So what is my hypothesis? How am I going to collect that data? What statistical tests am I going to run? What am I going to do to determine my outliers? What participants am I going to exclude from the analysis? So up front, I would make all of these decisions. And I can tell you this is really hard to do. It's really hard to think about, and there's often things that crop up. But doing all of this is really important. So that's one way that we can stop p-hacking and hacking. We can also encourage people to be a bit more transparent in the way that they share their data, their materials, their analysis code, so that others can verify their results. We can also make sure that people conduct more highly powered, so bigger studies that are going to minimize the chance of finding false positives. We can run these online for other people to verify your results. And there's also an argument that we need better theory. So one thing that I've kind of tried to move away from in your social cognition course, but if you did purchase the Fisk and Taylor textbook, one of my issues when I started teaching this is that there are just multiple different theories. It's almost like if you take a particular field, there is not one overarching theoretical perspective that explains what you would and you wouldn't expect to find. It's like researchers have come up with multiple different little pet theories based on their personal intuitions and expectations, and they end up testing all of these individual ones. So you end up with a field that has like 30 or 40 different mini theories. Yeah, which can be a little bit hard to work out which of these is correct and which isn't. So when we talk about pre-registration, I've covered most of these already, but yeah, the key thing is making sure that you register in advance your hypothesis and planned analysis. So making clear what is your primary outcome variable. So if I'm running the study on aggression, video games and aggression, when I think about aggression, what is the exact way, what is the way that I'm going to calculate that dependent variable? What is my outcome score going to be based on? Is it the score on one test? Is it the score on multiple tests combined, etc.? What is the exact way I'm going to analyze it? And am I going to use a t-test or an ANOVA? And I'm going to include covariates or not? When am I going to stop my data collection? How am I going to define outliers? Am I going to include covariates? So again, if we define all of those in advance, then basically your hands are tied and you can't p-hack that data. That's not strictly true. There are some cases where you can p-hack your data still, but let's assume that it does what it says on the tin. And generally researchers can do this quite easily using something known as the open science framework. So if you go onto there, you can create an account and create templates that will kind of take you through each of those stages. And ideally you want to pre-register this before your data collection. In an ideal world, you do it before. You can do it during, and worst case, you do it after data collection, but before you've looked at that data. It's slowly becoming the norm. So I don't have more recent trends on this, but in 2012, there was 38 pre-registrations. In 2017, there's 12,000. I would be confident that we are in the hundreds of thousands, if not millions by now. So it's becoming the default within psychology. And if you think of the benefits that this has for science, one of the nice ways that we can demonstrate this is, so this is, I want to see the x-axis on this. We're going to see the x-axis. Sorry. Okay, so this data comes from, you'll just have to take my word for it, that comes from medical clinical trials, where we're basically looking at what is the benefit of giving a drug. And from the 1974 up to 1999, when they introduced pre-registration in clinical trials, this is the distribution of effects that are found for drug treatments. And I think all of these pluses is where a trial shows a positive effect. So this period, we don't have pre-registration. Researchers can manipulate that data how they want. They can engage in these questionable research practices. If you now introduce pre-registration and look at what happens to the primary outcomes afterwards, we now see almost all of these studies report null effects, and there's only a couple of studies that are showing positive effects. And just look, it's a dramatic difference between the distribution of findings that are here. And we can think that this is probably the true nature of the effects. And this is just showing the impact of what happens in a drug trial when you can manipulate the way that you analyze that data. And there's no reason not to expect a similar sort of trend that occurs with psychological findings. So that's the main sort of benefits of doing this for science. There's also a lot of benefits at an individual level for researchers as well. So previously there used to be an actual financial incentive for pre-registering your data. There's something, these are a little bit silly, but you can also get what are known as pre-registration badges. So if you pre-register your study and publish it in a particular journal, so for example, Psychological Science, when that paper appears in the journal, there'll be a little badge that comes at the top that basically says your study is pre-registered, and it is designed to give you a little bit of extra kudos. So it's a marker. Now, the final thing I'm going to talk about with pre-registration is this slightly novel but increasingly common form known as registered reports. And I really think this is the future of the field of science. And this really flips the entire model of research on its head. So pre-registration is just the idea that we go and record our methods and our plans privately. So we record it on the open science framework, and it gets a kind of frozen version that we can't edit. Now with registered reports, what we can do is you would submit your pre-registration. So you would take your introduction, you'd take the method section, and you would submit that to a journal before you've collected any data. So if we look at the steps here, you submit it to a journal, the editor will have a look and will go, yeah, is it okay? Is it not? If he says it's okay, he will send it to some expert reviewers to read through. And they will peer review it at this stage. And basically, if they think that your introduction and methods make sense, that they're rigorous, they will give you what's known as an in principle acceptance. So what that means is basically you can go off and go and collect your data according to the methods that you said you would run that study. And irrespective of the results that you find, so whether you find a significant effect or you find nothing, they will publish that paper in their journal. So you'll then run the study, you would send it back for another round of peer review. And generally that will review the results in the discussion to indicate that they're written up in a way that follows how you said you would do things. And then you get accepted for this. And there are a huge number of journals that are currently accepting this approach. I think when I wrote these slides a while ago, there were 200. There are now thousands that do this. And I think this really is the future. So the benefit of doing this is that you are encouraged to focus on designing studies with rigorous methods rather than caring about the results. So if you're guaranteed to get your paper published, it does not matter whether you find a significant effect or not. So as a researcher, you can just kind of sit back and know that I'm going to collect that data. And in a way, I don't really care what I find. You're sort of liberated from this and there's no pressure. So again, the benefit of that as you as a researcher is that you're guaranteed a publication. You also get early feedback. So typically in science, what we do is we collect the study, we run the study, we collect the data, we send it off for peer review. It gets peer reviewed and the peer reviewers might criticize certain elements of the way that you've designed the study. They might criticize your results and they're like, wow, why didn't you run it this way? And with the registered report, the reviewers are coming in at the early stage. And essentially what they end up doing instead is offering you constructive criticism. So a reviewer might say, you know what, the methods that you've chosen, they are okay, but there's actually a better approach that you could take. And when they tell you in advance of you running the study, you can actually make these changes. So in other words, the peer reviewers are actually making a useful contribution. And again, I think the main benefit for science is just it reduces publication bias. It reduces everything to do with p-hacking and questionable research practices. And you can see some of the evidence here in the way that it reduces these publication biases. So what are we plotting here? So these are the percentage of studies that are published where the hypothesis, so your prediction, is not supported by the outcome in the research paper. And if we look at the general literature, so only 5 to 10% of papers show null effects, so where there is no statistically significant effect. If we look at how the changes of registered reports for either novel or replication studies, over half of these studies are not finding a statistically significant effect. It's quite a massive difference there. I'm going to go through the rest of these very quickly. There's also a real encouragement just to share data and make materials much more accessible. So originally, when psychology started off, there wasn't much in the way of a system set up for you to share your data. And a lot of the time, that is why some of the kind of statistical tests were introduced, because you can't share the raw data. So we need to reduce this data down into a kind of bite-sized format that's easy to introduce. In modern day, it's very easy for us to share all of the data that we get from our research findings. And there is a steady shift towards encouraging researchers to share their data more often. So that's driven by, one second. I don't know how to get rid of this really annoying little presenter thing at the bottom. Let's just assume it will disappear at some point. So there's a encouragement at the moment of journals that might sign up to this transparency and openness promotion guidelines that give journals different policies about transparency standards. And that means that journals are actually encouraging researchers to share their data. There's different levels of strictness that they might have, but in almost every publication that I've submitted over the last few years, it's a requirement that you either publicly upload that data or you make a very clear reason why that data isn't available. And that might be because it's sensitive, because there's ethical reasons that you can't reduce it. But I think for the majority of research that is done, it should be made open and accessible. So it's easy to upload it, basically. There are very easy, standardized ways for doing this. And it has a lot of benefits for you as an individual, as a researcher for doing this, that a lot of the time it makes that data much more available to the future version of you. So if you go to the effort of, when I've run a study, that I make that data really easy to interpret. So I save it and everything is explained very well and it's shared somewhere publicly. That means that it can't get lost when I lose my computer or I move universities. And it's also really easy for me to go back and interpret that and rerun any analysis. So a lot of the times open data is really useful for you, but it's also super useful for maximizing transparency. If you've got duplicated research programs, then sharing this data and allowing other researchers to see this means that they can maybe reanalyze it or combine it with their own data and maybe publish an additional study. It can also help with the accuracy of a lot of the meta-analysis that we've done. And I think one of the really important reasons is that it helps detect fraud, but also errors in reporting. So one of the most famous cases of this was there's two economists known as Reinhardt and Rogoff that published a paper making a big argument for the importance of, what's the word, of fiscal, what's the word for fiscal tightening? What's the economic policy? I can't think of the word now, but there was a policy, for example, that was implemented in the UK where they try and reduce spending as much as possible. So you try and limit the amount of expenditure on kind of public health to basically tighten the balance. So in times of economic crisis, that is the best way to get your country out of the policies of austerity, financial austerity. Thank you to my wife. And this had massive implications for the way that many countries approached economic meltdowns. So they basically kind of tightened the sort of, really struggling with words, tighten their wallet, stop spending money on everything that they possibly could, often at the detriment and harm to those that were the least economically well off within the society. And it turned out that a lot of this was based on some faulty analysis. So there were some lines of code that were in an Excel sheet that they had miscoded, basically. So the outcome variable was giving the wrong thing. And when you change this, it sort of flipped in the reverse. And it actually turned out that what you should be doing is spending money would help you get out of this economic crisis quicker. And these are examples where if that data was shared much more open from the start, that these sort of errors will get detected much more quickly. And certainly when they have important economic consequences like this, it's really important. There are some objections to data sharing, which I've included on here, none of which I think are really justifiable for the most part. So sometimes you might say that participants' anonymity and their consent. So for many studies, we can just use the identified data. So you can take away anything that's identifiable, upload this, and nobody's going to know who each of those participants are. I'm going to skip over those for now. There are a bunch of barriers that are perceived by psychologists to data sharing, typically based around the fact that it is not the norm. So if we look at on here, what we're plotting is responses on Likert scales, where the light and the dark blue indicate agreement with each of these statements. So for the top response here, the majority of people agreed that sharing data is just not a common practice in my field, then people say I just prefer to share data upon request, or preparing data is too time consuming for me. Which the second that I want to kind of somewhat, you could legitimize those responses, but certainly with the most important one being just it's not common. It is not the norm. And certainly when I speak to Thai colleagues, there is a general fear, almost like a repulsion with the idea of sharing data. But I think this is going to become, over time, a much more normative action for researchers. And some of the fears that come from this is that maybe if I put my data online, people are going to misinterpret it. Maybe they'll take my data and I'll be scooped. I might lose the intellectual property, etc. And again, I'm not going to go through these, but generally all of these critiques, there are systems that we are working through as a field right now to work out what are the ways that these things can be minimized. And generally for most of them, they're sort of very unlikely. Another point is, if we want to trust our effects more, we need to run higher powered studies. So if we conduct underpowered research designs, in a sense, they are unethical. So if I need 200 participants to know whether an effect is going on, and I just run that study with 50, and it's not going to give me a clear insight into this, you could argue that is a waste of resources. It's a waste of 50 participants coming into the lab and running a study. And it is one of the kind of main causes of this untrustworthy research findings. So we need to design studies that are powered to detect an effect. And a lot of the time that might need or might mean, as a field, that we just slow down a bit. So rather than publishing 5 studies in a year that all have small samples, what would be much better for science is if each researcher published 1 paper or 2 papers per year, just with much bigger samples and much more rigorous methodology. And there has been some sort of slightly flippant discussions over whether there should be a publication restriction for researchers, that you could actually limit and say, you know what, you can only publish 2 papers per year. And that will go some way to just increase the quality of the research that is being done. Whereas the problem is at the moment is everybody is competing for academic success and prestige, and everyone's sort of competing to publish as much as possible. So in order to do this, rather than necessarily slowing down for yourself, one of the other big shifts that have been going on in psychology is this move towards big team science. So one of the projects that I've been involved in a lot, which I think is really important, is something known as the Psychological Science Accelerator. And this is a collaboration of over 500 labs right now that would run the same study in different locations around the world, and then would publish a paper that contains data from tens of thousands of participants to study a particular effect in huge amount of detail. So this is stuff where I reported to you some of the findings from studies that we examined, Todorov's competence and warmth dimensions in face perception. Now, again, a lot of the work that's been done on this is pretty robust and good anyway, but it wasn't necessarily done across multiple different countries. And it certainly wasn't done with the level of detail that I think we ended up with over 28,000 participants that studied this. And that makes a lasting, really strong contribution to the psychological literature. The challenge of that, though, in doing these big team science is that it's harder to get recognition and prestige. So you're contributing like one small little bit to this big paper, whereas a lot of the time you get prestige and much more academic recognition from contributing big bits to small research papers. Again, I mentioned, I think, yeah, we do need to encourage more replication studies. So certainly incentivizing researchers to conduct them. And there are journals now that are increasingly more likely to publish replication studies. There are a version of the registered reports that are specialized for replication studies. It's becoming part of undergraduate education. So I mentioned that I incorporate this. There are the Collaborative Replication for Education project in the US that has undergraduate seniors engage in replications of existing literature. There's a researcher, Gilad Feldman at the Hong Kong University, who does so much amazing work on this that I'd recommend checking out. And yeah, I think the most important thing is just this general acceptance from journals. There's another issue that I'm going to skip over, but I think is important, is open access. So for you guys that are working at home, not using the university VPN, one thing you might come across is that a lot of these papers that you maybe want to read are a bit of a nightmare to get hold of and download. So maybe there's some that turn up to be on a PDF, or I send you a Sci-Hub link and we take the illegal back channel route to downloading it. Or maybe you log in through the university's VPN and then try and remember to log off before you go on any websites that you don't want the university to necessarily know you're on. I can't remember what I was searching the other day. Definitely, it wasn't pornography, but it was something that I maybe wouldn't want to have on my university web account. Yeah, anyway, we'll forget about what that was. Yeah, I just remembered I'm recording this lecture. So yeah, there's a real encouragement at the moment towards, rather than just publishing stuff and only making it accessible to academics or people that are willing to pay a subscription to journals, that we make things openly available to everybody, including the general public. So there's encouragement at the moment to make things open access and to post things as preprints. So these are just a list of different preprint servers that relate to specific fields in psychology. So the one in psychology is PsyArchive. And you can publish different forms of articles. You can publish something that you're currently working on that isn't peer reviewed. You can publish something that has been peer reviewed, or you can publish the kind of copy of the final version that's up there. Yeah, again, basic benefits that it can have benefits in citations for researchers, but I think more broadly, it allows everyone to be able to access and read your work and speeds up scientific communication. So I think one paper that I put up there a couple of years ago has already had 1,200 downloads of it. And I don't think it would ever have that many downloads if I was relying on people going to this journal article in order to download these. Okay, we're getting towards the end. There's also a need for better theory. So Michael Muthakrishna and Joe Henrich, who are both just phenomenal researchers. Joe Henrich has a book out at the moment called The Weirdest People in the World, that if I could recommend that you read one book, I think it's generally one of the best books that has been written in the last decade. So they make a claim in a paper that discusses theories. A large part of the problem is the lack of cumulative theoretical framework or frameworks. Without an overarching theoretical framework that generates hypotheses across diverse domains, empirical programs spawn and grow from personal intuitions and culturally biased folk theories. By providing ways to develop clear predictions, including through the use of formal modeling, theoretical frameworks set expectations that determine whether a new finding is confirmatory, nicely integrating with existing lines of research, or surprising, and therefore require further replication and scrutiny. So one of the things that this is kind of alluding to in more simple terms is if you're just relying on hunches of, I expect this to happen, it's a lot harder to understand when your results come out, whether they fit or don't fit your predictions. Whereas what might make more sense is to turn your theories into proper mathematical models that can then kind of simulate and would predict what are the different outcomes based on all of these inputs that you're specifying to the model. And then we can see, do the results actually fit this model that we've created well, or do we need to update and adjust the theoretical model that we've presented? Whereas most research fields go on without any overarching theoretical model. One question I didn't answer earlier on pre-registration is, does pre-registering your findings and hypotheses have any impact on the credibility and reliability of the study? Yes, massively. At an individual level, if you are reading a study that has been pre-registered, I would have so much more faith and trust in the results and the findings, as opposed to if that study was not pre-registered. In fact, I'm very skeptical of most stuff that is published out there that isn't pre-registered. And I think you should share that skepticism. The only variant to that is that some studies might have multiple. So some papers might have multiple studies, and you might see the first 2 studies are not pre-registered. And then if they find an effect, they might run that study again whilst pre-registering it. And in those cases, yeah, I would trust those studies if the pre-registered one is consistent. So in terms of where we are now, this is a paper written 3 years ago that quotes, if a team of research psychologists were to emerge today from a 7-year hibernation, they would not recognize their field. Authors voluntarily posting their data, top journals routinely publishing replication attempts, hundreds of researchers pre-registering their studies, enormous increases in sample sizes. Overall, an unprecedented focus on replicability. What on earth just happened? So I don't think we're quite there. This is quite an optimistic take, but I think it at least gives some of the idea that we have really shifted the field of psychology, that from 2011 to 2018, and things have only progressed more from there, there are massive seismic changes in the way that the entire research process is conducted. So stuff is happening. That's not to say it's happening everywhere. There are subfields where, yeah, I don't think much progress has been made. But I think in general in psychology, this is going well. Now I've put in here, if you are interested in this sort of, and we call the approach to improving the way that science is done, is given this term of meta-science. And if you're interested with some of these ideas of meta-science, some further reading or listening up here, one of my favorite podcasts features 2 psychologists, Joel Inbar and Mickey Inslicht. It does what it says. Actually, it doesn't do what it says on the tin. It's called 2 Psychologists, 4 Beers. And it's basically the idea that the 2 of them sit down and they have a couple of beers each and they chat about psychology. Mickey Inslicht always has 2 beers. The other guy, Joel Inbar, will often have like a soft drink or maybe like a white wine spritzer or something. Yeah, they maybe need to rename their podcast. Another podcast, Very Bad Wizards, features Dave Pizarro and Tamla Summers, so a psychologist and a philosopher. It's just a phenomenal podcast that if you want anything to listen to over the summer break, dig into some of these episodes, and I think you'll love them. Everything Hurts. That is a podcast by Dan Quintana and James, I can't remember his name now. So 2 psychologists, physiologists. There's The Black Goat, which is 3 personality psychologists, and a bit more of a methodological. One is Quantitude, which you can probably tell by the name. Social media, Twitter is a phenomenal place to go and understand open science and just psychology in general. I use my Twitter as an interface for academic conversation. There's also Facebook. And if you want some final further reading, these are my 3 top recommendations published last year, this year, and a couple of years ago. So Stuart Ritchie's science fictions, that would be number 1 go-to. And I think that will, if you read that, that will change the way that you approach everything that you read in psychology. The Quick Fix, I haven't read it, but it's by Jesse Singal. It came out this month, and I think it'll be a great overview of some controversial areas in psychology. And then this book by Chris Chambers maybe focuses a bit more specifically on some of the questionable research practices that we've covered. Okay, sorry, that was an absolute beast of me going through stuff and talking. So if you're still there awake and listening, congratulations, you're maybe in the minority. But I hope you found that stuff interesting. If you've got any questions on the final exam or stuff, so the final exam is going to follow the typical format of having multiple choice questions and short answer questions. The instructions will be uploaded on Blackboard. I'll do that today. So as you did for the Intro to Cognition last year, there's an instruction sheet that you need to read that explains about the midterm exam. So you can read that anytime between now and next week. And then when it comes to next week, the multiple choice and short answer questions will be available online. So I'm going to pause